All right, we're starting section 2.1, titled Congruent Figures. So this chapter 2 that we're in is all about geometric transformations, or how you change a shape along that's already plotted on the coordinate plane. Okay, so there are different ways we can do that, but the first thing we're going to talk about is what does it mean for two figures to be congruent? Does anyone know what that word means? You might have even seen this on your NWEA test. Jimmy, what's congruent mean? That's exactly what it means. Congruent figures have the same, I'm going to reverse it around because I think my blank's longer here. The same shape and the same size. Essentially, they are exactly the same. Okay, but you might even say they're equal. Now, we don't actually use an equal sign when we're talking about congruent figures. The congruent symbol looks like this. It's an equal sign with a squiggly line above it. The reason we say congruent instead of equal is because back in the olden days, back when the Greeks were doing a lot of the geometry stuff in the world, they only considered numbers being equal. If you said two shapes or objects were equal, you didn't use the word equal, you used the word congruent. And so they had a different symbol for that. So congruent is what you say when you're saying two lines, two shapes, two angle degrees are the same, whereas you put an equal sign if you are talking about x being equal to 7 or something like that. Essentially, it looks the exact same, equal sign with a squiggly above it. So congruent, same size and shape. Not congruent. Could be not congruent, just means they're not the same. That could be because they're the same shape, but not the same size, or they could be even different shape. We actually have a name for this. If they are the same shape and not the same size, we call that similar. We'll talk about that after I come back, here in a couple of weeks. We'll talk about similar shapes. So congruent means they're same shape, same size. Similar means same shape, different size. So for example, when you scale something, or you talk about a model version, like a little, what do they call those? Hot Wheels car. It's just like a car, shrunk down, right? So it'd be similar in shape, but not the same size, obviously. Okay. So in congruent figures, the corresponding sides and the corresponding angles are equal. Now, I just told you that they can't say sides and angles are equal. So what I should have said is that the measures of their corresponding sides and corresponding angles are equal. But I think you get the idea. So the word corresponding means the same side on a different shape, or the same angle on a different shape. So angle A corresponds on this triangle to angle D on that triangle. Also, segment AB corresponds to segment DE. Okay, so corresponding means the same line or the same segment or the same angle on the other shape. And so if the shapes are completely the same, then all parts of the shape will be completely the same. So the first thing we're going to do is we're going to start by labeling or answering these questions where we're naming the corresponding sides and angles of these shapes. So I have two, what do we call these shapes, by the way? What do you call them, Xander? Trapezoids. That's exactly right. Trapezoids have one pair of parallel sides. The other two sides are not parallel. These are trapezoids. What angle on the bottom shape corresponds to angle A? Sky? W. So what we're going to write is put an angle sign. This is the abbreviation for angle. So angle W. Geometry is all about labeling, whether it's labeling an angle degree or an angle itself or a line segment by putting a bar above it, or a ray. Do you guys talk about rays, lines, and segments a few years back? Okay. Yeah, the ray has one arrow and the lines have two arrows, and it's all about labeling. Angle B. Angle B, what does that correspond to? Go ahead. Angle X, that's right. Nice job, Garrett. Angle X. Angle C corresponds with what, Christian? Angle Y. And angle, hold on a second. There we go, put that over here. And angle D corresponds with what, Dawson? Angle Z. Now let's do the same thing for the segments. Oh, and what segment does segment AB on the top trapezoid correspond to? WX. Now, it's actually really important. I'll talk about this more in a second, but it's really important that we label it in the same order. So the fact that they said AB means we have to go WX and not XW. The order is important. So A to B means W to X. We have to list it that same way. So in that sense, if I'm doing BC, then Emerson, how should I label this segment? Yes, segment XY. Nice job. So there are no arrows on that segment bar because it's finite. It doesn't go on forever. So that's why I'm putting just a bar above it. Segment CD on the top trapezoid is corresponding to what segment on the bottom one, Lucy? That's right, segment YZ. And then segment DA on the top trapezoid, Xander?
ZW.
ZW. If you can do that, you can probably handle most of this section. This chapter's got a lot of vocab in it. Now the other sections get a little bit more complicated. It gets a little bit more complicated as we go. Once we start talking about transformations tomorrow's a really easy one. Friday's a really easy one. Monday is the hardest one with rotations. They get a little bit more complicated as you move through it. Now, a congruence statement. That's where you actually list, just like we did here, everything's got to be in order. Now they want you to write a congruent statement for these two triangles. So we abbreviate triangle by literally drawing a triangle. And so I'm going to call the top triangle, triangle ABC. And then I'm going to say that's congruent to. Now, because I told you the order matters, if I go A to B to C, that means I have to go D to E to F. Now you may be asking yourself, why is that so important? Well, a lot of times the two triangles will not look exactly the same. Maybe one of them, same size, same shape. Maybe one of them has been rotated, reflected, translated, or all three. And so it's hard to tell which angle matches up with the other ones. And that's why these congruent statements come in handy. So we've got our congruent symbol. That's a terrible looking congruent symbol. I can do better than that. There. And so I've got triangle ABC is congruent to triangle DEF. What if I would have said, and you don't need to write this down, I'm just going to write it. What if I would have said triangle BAC? If I said triangle BAC, what order would I have had to put the letters in on the second triangle, Maddox? EDF, exactly. BAC, then I have to put EDF. So therefore, let's write a congruent statement for this shape. How many sides does this shape have? How many, Lizzie? 5. Do you know what we call a 5-sided shape, Lizzie? It's a pentagon, that's right. We don't have a fancy symbol for pentagon like we do for the triangle. So I'm just going to abbreviate pentagon, the word pentagon, by putting pent. And then Lizzie, I'm going to let you pick the order that we write the letters of the first pentagon. I do not care what letter you start at, but when you're writing congruent statements, we didn't have to worry about this for the triangle, but when you're working with shapes that have more than 3 sides, once you pick a letter to start at, you have to go either clockwise or counterclockwise. You can't say L to J to M to K to N. You can't make like a little star. You got to pick one side and either go clockwise or counterclockwise. So you pick your letter, J, and then do you want to go clockwise or counterclockwise? Okay, so that would mean J, N, M, L, K. That's going to be congruent to, shrink this down just a little bit, or I'll just put it down here. That's going to be congruent to pentagon. What order do we have to go in? This one's a little bit more complicated because they didn't give you all the markings that we had over here. So she started with J. What angle on the other pentagon corresponds with J? Go ahead, Julia. It's S. And then because she went this way, what direction do you think we should go starting at S over here? Should we go, what would this be? Clockwise or counterclockwise? Yes. That is correct. Yeah, it looks like these lines are really almost the same length. Maybe this was a little shorter, maybe this was a little shorter. But what's giving this away is the fact that this angle, this right angle, she's working towards the right angle, going to this horizontal line here. We see the same pattern here. There's a horizontal line with the right angle. So we're going to go S to T to V to Q to R. And then every letter is in the same exact order. So if I told you angle S, or we'll say J, the one that Lizzie chose, if I said that it was 50 degrees, you know that since J corresponds to S, S also has to be 50 degrees because everything on these shapes is the same. If I told you that LM was 2 centimeters long, you know from our congruent statement that LM corresponds with QV. So it also has to be 2 centimeters long. And you can use those statements to kind of fill in all the missing parts if you needed to. Like I said, it's a lot easier when they use tick marks. At least that's what some people call them. And so tick marks show you which sides and which angles are congruent. So the side that has 1 tick mark up here is congruent to the side that has 1 tick mark. The ones that have 2 tick marks are congruent. The ones that have 3 tick marks. Same with the angles. Angle B has 1 angle mark, tick mark. Angle E also has 1. Would have been a lot easier to do this one if they would have put the tick marks here. Also would have been a lot of tick marks though. So, which square is congruent to square A? Carter.
Square C.
Why do you say square C? Because it looks like it's been tilted. Does that make a difference?
No, it's got the same sides.
Exactly. Square C, even though it's been rotated, doesn't mean the shape has changed. To be congruent, you have to have the same shape and the same size, and you are correct. Square B has the same shape, but square B has a different size, and so it cannot be congruent. You would say they're similar, but not congruent. Same shape, different size. Trapezoids A, B, C, D, and JKLM are congruent. I need to know what the length of JM is, the perimeter of the entire shape, and then the angle. So I want you to think about this. See if you can answer based off of the values that they gave us for this trapezoid. Can you answer these 3 questions about this trapezoid? Take a minute to look at that. By the way, we are going to dismiss at the 2nd bell. Okay, so at 1:45. Oh, where's that? No, not 1:40. 1:05 is what I meant to say. So we're going to dismiss you guys. You'll still get your pass period. You'll still get your 5-minute break. We're just going to extend class 5 minutes longer because I've got the other class for like another 45 minutes. And they're going to drive me crazy. So, all right. Oh, I need to teach that class some manners. All right, so we got 5 minutes. What is the length of JM? What do you got, Xander?
10 feet,
How did you get 10 feet?
because AD is the same line segment.
That's right. So AD is the same as JM. So when it said JM, and guys, I know you're like, why are you even looking at that up there? Well, I'm going to show you here in a second, but they haven't been rotated or reflected. So it's really easy to see that this segment here, AD, is the same as JM, so it's got to be 10 feet. But the congruent statement confirms it. What about the perimeter then? What do you have, Christian? 32 feet. So the perimeter of the first trapezoid has to be the same. That's right. If all the line segments are the same, that means the perimeter is going to be the exact same and the area would be the same as well. What do you got for the last one, Shane? Angle L. Yeah, angle C and angle L are going to correspond to each other. And if you look up here at the congruent statement, angle C, angle L, they do correspond to each other. Now let's take that and let's apply it to one that has been rotated. This might be a little bit more difficult. Well, if you're trying to just look at it, but if you use the congruent statement, you can match each of the angles and each of the segments up using the congruent statement up here at top. So let's start by finding X. No, literally, where is X? Which trapezoid is it on? The first one or second one? Do you see it, Xander? First one. X is right here. It's part of the line segment RP. So I find RP. I know RP has to correspond with WV. WV is right over here. So if you were thinking it was the shortest side on that side, it should be the shortest one on this side, you are correct. So RP is going to correspond with WV, which means X plus 5 has to be equal to 12 because on congruent shapes, the corresponding lengths, side lengths are equal. So if X plus 5 equals 12, what does that make X equal to, Carson? 7. Okay. It's a different color here. Now we're going to find Y. Where's Y at? You see it, Shane? Where's it at? The second quadrilateral. That's right. Right there. It's T. It's between T and W. So if I know what segment, if I know that it's on segment TW, which is here, I know TW has to correspond to QP on the other shape because they're listed in the same order. So PQ is right here. So this line and this line correspond, and that makes them the same exact measure. So 6Y has to be equal to 24. What's that make Y equal to, Jace? Y equals 4. All right, and the last one, Z. Where can I find Z at, Carson? Yeah, it's actually an angle measure this time. So there's 11Z, and 11Z is actually referencing the measure of angle V. Well, the measure of angle V has to be the exact same as what angle in the first quadrilateral? Jimmy? R. And if R is 132, then 11Z has to be the same as or equal to 132. What does that make Z equal to? Dawson? 12. The congruent statements definitely make a bigger difference when you have shapes that are rotated around. It's a lot easier to match them up. This shape was really easy to do, but when they rotate them and reflect them and all that stuff, the congruent statements come in handy. Okay. Your homework tonight is on big ideas. However, you are taking a picture of your work paper, which might just be an answer. I get it. It might just be an answer paper. Okay. Instead of saying no work paper, I thought this would be a good chance for us to practice taking a picture of our work paper and posting it to Google Classroom. For those of you wanting to write all your answers on Notability, you submit that document and just make sure they're numbered. That's us. You guys still get 5 minutes. Take your restroom break, and I'll see you tomorrow. No, you're gonna stay over there until we get back. I saw you for 3 periods yesterday. How much more do you want to see me, Xander?
Yeah.
Did you have answers for like